Hey guys, Tyler here. The Bajoran Wormhole, first seen in the Star Trek Deep Space Nine pilot Emissary, is the only known stable wormhole during the 24th century in Star Trek's Milky Way. Discovered by Starfleet Commander Benjamin Sisko and Lieutenant Jadzia Dax, the wormhole connects the Bajoran system in the Alpha Quadrant with a terminus in the Gamma Quadrant on the opposite side of the galaxy. The wormhole is home to a race of extra-dimensional beings who are worshipped by the Bajorans as gods, whom they call the Prophets. And naturally, the discovery of the wormhole put Bajor on the map, so to speak, and completely transformed interstellar commerce. In this video, I'd like to examine the science of the Bajoran wormhole, comparing it to our expectations about wormholes in real life, if they exist. Let's get started. The two termini of the Bajoran wormhole are normally located almost 90,000 light-years apart. The Alpha Quadrant terminus, or mouth, lies in the Denorios belt of the Bajoran system. The Gamma Quadrant terminus is located 4.7234 light-years away from the Edron system. Prior to the wormhole's discovery in 2369, it would have taken the fastest Federation starship at least 67 years at maximum warp, non-stop, to cross this distance, which is of course impossible. But the wormhole cuts this travel time down to mere minutes. According to Emissary, because of its stability, the wormhole does not have any of the usual resonance waves of other wormholes. In other words, the Bajoran wormhole does not oscillate to the same extent that makes other wormholes untraversable. Starfleet scientists theorize that the Bajoran wormhole is made of verterons, self-sustaining subatomic particles that can travel faster than light. While such a particle would be deemed impossible under special relativity, Star Trek seems to, pardon the crude metaphor, have a boner for proving Einstein wrong. That is to say, the verteron, which various tie-in media suggests has a subspace component, operates in dimensions beyond our normal 4D space-time. In fact, the DS9 technical manual confirms the Bajoran wormhole's interior consists of a 12-dimensional helical verteron membrane, an apparent reference to string theory, creating the tunnel shape of the phenomenon. According to various episodes, highly elevated neutrino levels are also commonly detected prior to an appearance of the wormhole's event horizon. Neutrinos are, of course, incredibly tiny, electrically neutral particles with near-zero mass that only interact via the weak nuclear interaction and gravity. Neutrinos do not participate in the strong interaction, meaning they typically pass through normal matter undetected and unimpeded, which also includes my body and your body, possibly right now at this very moment. Some black holes are known to produce them, for example, and neutrinos are among the most abundant particles in the universe, 1 billion times more common than the particles that make up stars, planets, or us. And just on the side, even a banana emits neutrinos. They come from the natural radioactivity of the potassium in the fruit. So from now on, some of you will probably look at bananas in a different light, huh? In real life, as I alluded to, wormholes are not yet confirmed to exist. They're entirely hypothetical, serving primarily as a solution to some of Einstein's field equations. While I just got through describing how Star Trek likes to prove Einstein wrong, that's not entirely accurate. Einstein's theories of general and special relativity are still fundamental to our current understanding of physics, and form the basis of many aspects of Star Trek science too. But the thing is, Einstein's theories are incomplete. That is, parts of them conflict with quantum mechanics, which describes the nature of the subatomic world. This conflict is what defines the search for a grand unification theory, or the so-called theory of everything. String theory, which posits extra dimensions that are compactified and could describe the origin of gravity, is one possible theory of everything. But we can't know for sure until we get some more experimentally proven data. And when it comes to theoretical physics, That's often easier said than done. And of course, string theory isn't the only game in town. There's also loop quantum gravity, among others. But back on the topic of wormholes, at least one theoretical model suggests they could arise from cosmic strings with negative mass that formed early in the universe. Negative mass is, of course, a phenomenon I've invoked before on this channel, a type of exotic matter often used in speculative technologies like time machines and faster-than-light engines. The closest known real example of this exotic matter is the negative pressure density produced by the Casimir effect. In experiments that demonstrate the Casimir effect, virtual particles spontaneously arise and dissipate due to fluctuations in the so-called quantum vacuum, the lowest energy state of a quantum system. Virtual particles with wavelengths wider than the separation of two metal plates placed nanometers apart exert a negative pressure that brings the plates together. It's the negative energy produced by this interaction that some physicists, such as Miguel Alcubierre, believe could be taken advantage of in order to power hypothetical faster-than-light engines. And of course, in Star Trek, warp drives rely on the fact that space can expand faster than the speed of light, with the drive contracting space in front of the ship and expanding space behind it to go where no one has gone before. Despite being, again, entirely hypothetical objects, there are actually different types of wormholes in science. The most frequently discussed type in science fiction, in my experience, is a Schwarzschild wormhole, or Einstein-Rosen bridge. Einstein-Rosen bridges extend the Schwarzschild metric, a solution to Einstein's field equations, to describe a so-called eternal black hole, one that has no charge or rotation. In addition to black holes, the Schwarzschild metric is used to describe white holes, or a region of space-time that's the reverse of a black hole. It can't be entered from the outside, but matter, energy, light, and information can escape from it. But most black hole physicists don't take the concept of white holes too seriously, as there's no known process that can lead to their formation, though some have suggested the Big Bang could have resulted from a supermassive white hole explosion. In any case, however, white holes can't really be used to describe the behavior of the Bajoran wormhole. It can be entered and exited from both sides. Naturally occurring Einstein-Rosen bridges are expected to immediately collapse due to instability, though naturally occurring microscopic wormholes could be used to transmit information, like in the Voyager episodes Eye of the Needle and Pathfinder. But artificial, traversable wormholes, like the Bajoran wormhole, would almost certainly require negative mass. Physicists like Stephen Hawking and Kip Thorne have both argued it may be theoretically possible to build such structures in real life. Using exotic matter would be essential to keep a wormhole's mouths open and avoid falling into the gravitational singularity. This is also where two other solutions to Einstein's field equations come in, the Reisner-Nordström metric and the Kerr metric. I go into more detail about the differences between these metrics, along with the Kerr-Newman metric, in my video about V'ger, which you should check out if you haven't already. Link in the description. I'm really proud of how that video turned out. But suffice it to say, while a Schwarzschild black hole has no charge or spin, Reisner-Nordström black holes have charge but no spin, while Kerr black holes have spin but no charge. And by the way, I'm using spin as a shorthand for rotation or angular momentum. The most consistent description with our real-life observations of black holes is the Kerr metric, chargeless black holes with angular momentum. And it just so happens that the mouths of the Bajoran wormhole not only appear to rotate, but seem to be electrically neutral as well. There's so much more I could talk about when it comes to the science of wormholes, both in Star Trek and in real life. The fact is, their real-world theoretical nature has often led them to become associated with exotic processes like time travel and interuniversal travel. The latter is, of course, showcased in several Deep Space Nine episodes where members of the crew travel to the mirror universe. That said, while quantum mechanics may be entirely consistent with things like closed time-like curves and parallel universes, the paradoxes that can arise from this means that most physicists are not comfortable with backwards time travel or even FTL travel. They argue that a complete understanding of quantum mechanics would likely prevent such time paradoxes from being able to occur in the first place. But Star Trek deals with the fallout of such paradoxes all the time. Again, it's a very non-Einsteinian universe, one where string theory is essentially correct, and extra dimensions help explain all kinds of timey-wimey weirdness. As for whether or not that describes our universe, well, that remains to be seen. With that, thank you all so much for watching. If you enjoyed this video, be sure to leave a thumbs up down below and don't forget to share it. That stuff really helps me out. If you haven't subscribed yet, be sure to do that as well so you won't miss future uploads, and click the bell icon to receive all notifications. If you want to support my work even further, you can become a patron at patreon.com/OrangeRiver, link in the description, or become a YouTube member by clicking the join button on my channel page. By becoming a patron or member, you get access to awesome perks like behind the scenes photos and videos, patron and member only polls, name in the credits, merch discounts, and more. Speaking of merch, links to my store as well as my social media are also in the description. That's all I have for this week. Live long and prosper.